Good morning, all of you. My name is Saikram. I am your chemistry lecturer. In our last class, we discussed introduction about atom according to Dalton theory. Today, we will discuss subatomic particles of atom. According to J.J. Thomson, Rutherford, James Chadwick, Sommerfeld, from their respective experiments, they concluded that atom can further divided into three subatomic particles. They are electron, proton, neutron. Let's see one by one these subatomic particles, how they are discovered. The first one is discovery of electron with the help of cathode ray experiment. Cathode ray experiment. This is also called as discovery of electron. This was performed by J.J. Thomson in 1897. First, he took a discharge tube made up of glass. This tube was discovered by Sir William Crookes, so we call it as Crookes tube. This tube contains two metal strips. These two metal strips are connected with external battery at high voltage, that is 10 to the power of 4 volts. The metal strip which is connected to the negative terminal of the battery which carries negative charge, we call it as cathode. The metal strip which is connected to the positive terminal of the battery which carries positive charge, we call it as anode. He kept H2 gas inside this tube. He fixed vacuum pump over here. With the help of this, to maintain the low pressure inside the gas, that is 10 to the power of minus 2 mm of Hg. This particular side he coated with fluorescent or phosphorescent material like zinc sulfide. The property of this material is when a particle with some mass strikes this zinc sulfide screen, bright spots get created. This is the complete setup of cathode ray experiment. Now come to the observation. When he turned on the battery, he observed that some bright spots gets created on this zinc sulfide screen. Based on this, he concluded that some invisible rays which seems to be coming from the cathode to anode strikes this zinc sulfide screen, this bright spots gets created. Those invisible rays which seems to be coming from the cathode, he call it as cathode rays. Let's see the properties and conclusions of cathode rays. Now, he placed an object in between these electrodes. He placed a screen behind this object. When he turned on the battery, a bright image gets created on this screen. This is only possible when these rays are traveling straight line. The first property is cathode rays are traveling straight line. Now, he want to identify these cathode rays carry certain charge or not. For that, he placed a magnet in between these electrodes inside this tube. This magnet is associated with some magnetic field. We know that any charged particle passing through the magnetic field, its path gets deviated. Now, he turned on the battery, he observed that this part of the screen will glow continuously. Based on this, he concluded that these invisible rays path gets deviated towards this side. That's why this part of the screen glow continuously. Second property is this rays carries certain charge. Now he want to identify which charge present on these rays. For that, he placed two metal strips inside this tube in between the electrodes. These two plates are connected with external battery. This plate carries positive charge. This plate carries negative charge. When he turned on the battery, he observed that the path of these cathode rays deviated towards positive plate side. We know that same charges are repulsed, opposite charges are attracted. Based on this, he concluded that these cathode rays carries negative charge. These are negatively charged particles. Third property is it carries negative charge. So he called these cathode rays as negatrons. Later, this name was changed to electrons by the scientist Stoney. Eventually, this experiment was carried by different gases. He realized that these particles or these rays present in every gas. Based on this, he declared that these are the fundamental particles of nature. These are present in everywhere. And the nature of the particles does not depend on the gas taken into the discharge tube and independent of the material of electrodes made up of. Hence, he concluded that these electrons are basic constituent particles of all the atoms. Based on this experiment, he gave few more conclusions. Let's see. From this experiment, velocity of electron was calculated. For that, he arranged the electrical field strength and magnetic field strength perpendicular to each other. This electrical field strength is equals to Fe, magnetic field equals to Fm. Now, electron present here. At this point, this electron experiences two forces. One is due to electric field strength towards upside, and one is due to magnetic field towards downside. By carefully balancing these electrical field and magnetic field, it is possible to bring back the electron to its original path, that is undeviated. That is Fe equals to Fm. Electrical field strength equals to Q into E. Magnetic field equals to Q into V into B. Here, Q is the charge of electron, E is the electrical field strength, Q is the charge of electron, V is the velocity of electron, B is the magnetic field strength. Both sides Q gets cancelled. From this, we get the value of V. V equals to E by B. E is the electrical field strength, V is the magnetic field strength. He knows the both values. By substituting these two values in this formula, he calculated the velocity of electron, that equals to 1/10th of velocity of light. And now come to the second conclusion. From this experiment, he calculated specific charge of electron, that is E by M ratio of From this experiment, he calculated the specific charge of electron, that is E by M ratio of electron. J.J. Thomson measured the E by M ratio of electron based on 3 points. They are in the presence of electric and magnetic field, the first point, greater the charge on the particle, greater the charge on the particle, greater will be the deflection. Now, understand the first point. When charge on the particle increases, deflection increases. Charge on the particle decreases, deflection also decreases. So, charge on the particle directly proportional to the deflection of the particle. Now, come to the second point. Lighter the mass of particle, lighter the mass of particle, greater the deflection. Which means mass is less, deflection is more. Mass is more, deflection is less. Now come to the third point. When increase the battery voltage, when increase the voltage on battery, deflection also increases. Based on these 3 points, E by M ratio was calculated. Let's see how mathematically E by M ratio was calculated. These two are electrodes. These two are connected with external battery. This electrode carries negative charge, this electrode carries positive charge. Potential difference between these two electrodes is V dash. Now electron is present here. In absence of electric field, there is no movement of electron. So this electron associates with some potential energy. When battery is turned on, this electron moves towards anode side. That is electron in motion. So this potential energy converts into its kinetic energy. Potential energy equals to charge into potential difference between two electrons. Kinetic energy equals to half mv square. Here Q is the charge on the electron. That is equals to E. V dash is the potential difference between two electrodes. M is the mass of the electron. V is the velocity of electron. We know the value of velocity of electron. That equals to V equals to E by B. By putting V value to in this formula, then E into V dash equals to half M E square by B square. This M comes this side, this V comes this side. E by M equals to E square by 2 into B square V dash. He knows the value of electric field strength. He knows the value of magnetic field strength. He knows the value of potential difference between two electrodes because he adjusted all these values. By putting all these values into this formula, he calculated E by M ratio of electron. That is equals to 1.76 into 10 to the power of 11 coulomb per kg. 1.76 into 10 to the power of 8 coulomb per grams. He calculated E by M ratio of electron for different gases. Every time he got the same value. Based on this, he concluded that E by M ratio of electron does not depend on the nature of the gas taken and does not depend on the material of electrodes made up of. I will give you one important note. Calculation of E by M value of ions with respect to hydrogen atom. We have a formula that equals to magnitude of charge on ion divided by mass number of ion. Let's see one example. One example question. Calculate the E by M value of He plus 2 ion with respect to hydrogen atom. Now see the solution. E by M value of He plus 2 ion, that equals to magnitude of charge on ion, that is 2. Mass number of helium, that is 4, that equals to 0.5. This is how discovery of electron with the help of cathode ray experiment and E by M ratio of electron was calculated. That's it today class. In our next class, we will discuss how charge on electron was calculated with the help of Millikan's oil drop experiment and discovery of proton and neutron.